Welcome to Brain Vision.
In this problem, we want to calculate the differential of the tension. We know the tension in the string of the yo-yo satisfies the equation T equals mg, the uppercase R divided by 2 lowercase r squared plus uppercase R squared, where m is the mass of the yo-yo, g is the acceleration due to gravity, the uppercase R is the outer radius of the yo-yo, and the lowercase r is the inner radius of the yo-yo, like shown in this graph. So m and g are both constant, where the uppercase R and lowercase r are two independent variables of the function. If we want to calculate the total differential of this multivariable function, we can first write down dt, the total differential, is equal to partial t partial uppercase R times the differential of uppercase R plus partial t partial lowercase r times the differential of lowercase r. And we can denote this as our equation number 1. So now we want to figure out what is the partial derivative of tension with respect to the uppercase R and lowercase r. So partial t partial uppercase R can be calculated like we think this lowercase r as a constant and this uppercase r as a variable. So now we use quotient rule. We have the derivative of the numerator function, which is mg, multiplied by the denominator function, subtracted by the derivative of denominator function, which is 2 uppercase R, multiplied by the numerator function, and then divided by the denominator function squared. And this is our equation number 2. Similarly, we can calculate our lowercase r by thinking about this uppercase R as a constant and the lowercase r as a variable. So the derivative of the numerator function should be 0 because this numerator function doesn't contain any lowercase r, multiplied by the denominator function, subtracted by the derivative of denominator function, which is 4 lowercase r, multiplied by the numerator function, divided by the denominator function squared. And this is our equation number 3. Now, if we plug in the equation number 2 and equation number 3 to our first equation, we can get dt is equal to mg multiplied by 2 lowercase r squared minus uppercase R squared, divided by 2 lowercase r squared plus uppercase R squared squared, multiplied by the differential of uppercase R, subtracted by 4 mg, the uppercase R, lowercase r, divided by 2 lowercase r squared plus uppercase R squared squared, multiplied by the differential of lowercase r. And this is our equation number 4. This equation number 4 shows a relationship between the differential of tension to the radius of yo-yo. So now we can plug in some conditions. We know the outer radius change from 3 centimeter to 3.1 centimeter. So the differential of the outer radius should be 0.1 centimeter. And the inner radius change from the 0.7 to 0.8 centimeter. So the differential of inner radius is also 0.1 centimeter. And we can denote this as our condition number 5. So now if we plug in our condition number 5 to our equation number 4, we can get dt is equal to mg multiplied by 2 times the inner radius function, the inner radius which is 0.7 and squared, minus the original outer radius, which is 3 squared, divided by 2 times 0.7 squared plus 3 squared multiplied by 0.1, subtracted by 4 times mg times 3 times 0.7 divided by 2 times 0.7 squared plus 3 squared multiplied by 0.1. After computing this, we get our final result is negative 0.0165 mg. Because both the mass and acceleration due to gravity are positive constant, so this negative 0.0165 mg should be negative. And since the differential of tension is negative, so we know in this case the tension will decrease.